The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Welcome to our webinar today on trends and challenges in smart factory. My name is Scott Siphon with Moxa, and I'll be your moderator for the day. Our presenter for today's webinar is David Garcia, one of our product marketing specialists here at Moxa. Just for background, David has spent the last several years working directly with many customers to understand and find solutions for their networking challenges in a factory environment. We're really excited for him to share his knowledge and experience with all of you today. Before we get things started, if you have any questions during the webinar, please submit them in the questions pane, and we'll try to address them throughout the webinar or during our live Q&A at the end. With that said, I think we're ready. Let me hand things over to David.
Hi, good morning, everybody. Welcome to our Smart Factory Trends and Challenges webinar. My name is David Garcia. Like my colleague Scott said, I am the product marketing specialist for IEI. Basically, that means I'm the switch guy. But yeah, I'm really happy to have everybody here today and share the information that we have for the webinar. So let's go over the agenda. So today's agenda is going to be about smart factory. So we're going to talk really briefly about a smart factory overview, some trends, then some of the top challenges in smart factory. And then we're going to jump into some solutions for some of those challenges. And at the very end, we'll leave a little time for questions and answers. All right, so let's get this started. So before we move into the actual topic, I really want to start with this, this quote. I think it's a really great quote that encapsulates what smart factory or IoT or Factory 4.0 is really all about. Anything that can be measured can be improved. So basically, anything that you can bring on board and get information about, you can definitely make better, either the process or in business. So just wanted to start that off with that. And next, let's go ahead and start off with some smart factory trends. So there's been some definite advances in manufacturing technology. There's been things like digitization, energy efficiency, mass customization, predictive maintenance, remote diagnostics and monitoring. A lot of that is basically because of demand for flexibility in manufacturing. And these are all some really great advances, and a lot of this stuff is for a lot of the newer equipment. Today, we're going to focus mainly on the legacy equipment, but what is it about the legacy equipment that makes people want to connect it? Well, there's some drivers behind Smart Factory for business. Specifically, improving your operational efficiency, improving your productivity, creating business opportunities, reducing your downtime, but maximizing your asset utilization. But of all of those, the top two that are actually the two adoption driving use cases for IoT are process improvement and predictive maintenance. So the reason for that is because you really want to be able to start analyzing exactly what is going on your plant floor. So figuring out what's causing your issues with your quality has a lot to do with getting the right analytics. So those are the key, and why your equipment is performing poorly, or when can you expect it to fail, or does your operator need some more training? Connecting your legacy just gives you the important data so that it can be validated, and by using those analytics, you can make better decisions about key performance indicators like your goals and how to hone in on exactly the ones that you should be focusing on. So incorporating preventive maintenance can tell you things like when you should be changing your tooling, if you should adjust the speed of the feed for the bar stock, or before it affects any of your production, instead of waiting to produce scrap and creating some waste, which is great because anyone who's ever managed the factory floor can tell you that maintenance schedule affects production schedules, right? So you'll become a lot more efficient. You'll learn important details about the production, how often you need to change your tooling, is tooling even an issue, what speed is optimal for improved consistent quality, and getting higher yields. It is better to run a whole job. Is it better to run a whole job on a machine or add other processes? There's literally no limit to how efficient your operation can become. So Smart Factory or IoT is really about providing actionable insights to your whole organization so that everyone can collaborate and make better decisions based on actual data that you gather from your operations. So this is a really great example of what exactly the ROI is on predictive maintenance. So on the left, there's a chart from the U.S. Department of Energy. It breaks down the ROI on predictive maintenance, which is pretty amazing stuff. Just the elimination of breakdowns alone is pretty huge. And to the right of that is an example of a dashboard, right? I guarantee that you already have all the same information in spreadsheets or written down in logs that you have to sort through, you have to run reports on, maybe just so you can make heads or tails of it. But the reason dashboards are so great is because they are providing you real-time and historical data in a way that is easy to understand. So no more my gut tells me or Gary thinks, you know, you'll be able to actually see exactly what's going on and how you can improve it. So speaking of the legacy equipment that we're trying to bring on board, there's a big trend right now for a lot of people moving over to Ethernet-based industrial machinery devices, right? So the great thing about that is that now you can take advantage of all those advances in manufacturing we talked about earlier, but there's still millions of proprietary legacy PLCs, serial devices, sensors that are still in operation today, and they're likely to be in use for at least another 10 to 15 years. The problem with these legacy OT networks is there's no data analytics, right? These are all information silos. They have different protocols, no comm interfaces, a lot of legacy software. So it's really difficult to access or share your data. So a smart factory, the goal behind it is to eliminate those information silos, collect that process data, analyze the data, all with a simple goal: drive continuous improvement, right? Like we said, anything that can be measured can be improved. So reliable network communication is definitely a big part of that. So now let's go ahead and talk about some of those smart factory challenges that are impeding people being able to take advantage of all that great new technology and gathering of information to share across departments. So first off, let's talk about the 4 challenges. So there's many challenges, but by far these are the top 4. And the first one is connecting your legacy devices, right? We have a lot of newer Ethernet-based industrial equipment, a lot of machines, devices, but we also have a lot of legacy devices being brought online. That can be a challenge because of the lack of protocol and interoperability or proprietary serial protocols, or honestly, just the lack of Ethernet port, you know, let's be honest. The second is the network complexity. So the more legacy devices that you bring online, the more sensors you add, the more complex your network is going to become, and the more difficult it can be to manage, especially if you need to communicate between different protocols, especially because of uptime, right? Uptime is obviously a must. Thirdly, we have the skills gap. There's a lot of people that are going to be retiring from the workforce. These people are experts who really have the knowledge and skill set to operate the legacy equipment, and they have the years of experience, and it's leaving with them as soon as they walk out the door. So finding the right people to train on these systems and also have the networking expertise is a really big problem across the board, regardless of what industry you're in. Number 4 is industrial cybersecurity. Because of IoT and smart factory connecting factory floors to enterprise networks to access that production data, it means that cybersecurity is an increased concern. Because remember, you're adding IP addresses and connecting legacy equipment to your network. This stuff was never supposed to be online. So if you're not careful, you can easily add hundreds of vulnerable access points to the factory floor that can be exploited, and that means your entire network is vulnerable as well. So this is not meant to scare you, but it's just really, it's important for everybody to be aware that these are some concerns that you should have and be proactive about all the devices you're connecting to your network and making sure that they're safe and protected. So let's go ahead and give it over to Scott so we can do our first poll question. Scott? So we're going to take a few minutes. We're going to give you guys. So let's go a quick poll. The first one is, what exactly is the biggest smart factory challenge that you guys see in your environment, in your factory floor with your business? Is it the legacy equipment integration? Is it the outdated systems, software? Maybe the lack of skilled personnel like we were talking about earlier, or is it network security? We're going to give you guys a few more seconds, and then we'll go ahead and close this poll out. I'd really love to know what you guys are seeing out there and what's going on. Obviously, if you guys are joining us for this this webinar, great, that's awesome. So we do have a lot of people that have a lot of legacy equipment that trying to integrate, and obviously lack skilled personnel. Awesome, that's really good to know, because this webinar is tailored specifically for you. We're gonna make it really easy and really simple. It's just a brief overview, but we're going to touch on a lot of topics that are going to be really important to anybody that's trying to do exactly what we just saw on the poll there, connect their legacy devices. So let's go ahead and get started with connecting legacy devices. So there was a poll done, a survey by Automation World that basically asked which devices are not connected. So a lot of it was no plant floors connected, but motors, instrumentation, sensors, drives, packaging machinery, quality systems, even historians were not connected. And a main reason for that is the fact that they're not Ethernet capable, just like we mentioned before. They don't have any real communication or any kind of Ethernet ports to connect them to your network to bring them online. The other one is the fact that because of that, they're using a lot of serial to Ethernet converters, which is a really great option for anybody looking to bring those legacy assets online. All right, so now here we have the why I'm not online trifecta that is keeping most of our customers from reaching the big data goalpost. The key here is interoperability across your devices and your protocols, but you have communication devices that legacy devices without any interfaces. You have a lot of proprietary protocols. You also have a lot of different protocols. You might have a plant that has both Modbus and Ethernet IP and maybe some Profinet. So having the ability to have all those devices communicate and be able to gather all the data from them is huge because, like we said, we want to get the data to improve our operations and our efficiency. So we're going to start off by talking about I/O. Okay, so a major concern for people is how do you monitor those digital and analog signals from your equipment on the factory floor, right? You're going to need something that has support for multiple protocols. You need Ethernet IP, Modbus, RESTful APIs. There's a lot of data that gets gathered and put on dashboards like I displayed earlier. There's also deployment and installation costs, right? You might have some limited space on your PLC backbone and you want to save some installation time, but you want to add some sensors to monitor. Also, there's various I/O needs. You need to find solutions that work with both your digital and your analog signals for different I/O quantities. So let's take a quick look at the current process right now for adding some discrete I/O and what that actually entails. So it's going to involve some programming, some wiring, right, some conduit, and also some installation. So the labor equals downtime. The additional cost of having to run 60-foot plus shielded cable runs, that adds a lot of cost as well. And not to mention the resources needed to program your PLCs and to be able to integrate those different sensors, right? So a really great option that we found is reducing the cost through remote I/O. For instance, this is an I/O logic. So you're able to use it to daisy chain your different I/O points. You can use Ethernet cable to extend that cabling all the way down to where you actually need that I/O point added. So you have a shorter cable run. It has a lot of different protocols that it speaks from Ethernet IP to Modbus. It does SNMP, and it can even do peer-to-peer. So you might not even need to configure anything on your PLC or your HMI. They can talk directly to each other. It's a really great, flexible, quick I/O, easy to troubleshoot solution for anybody that's looking to add a couple additional I/O points, right? Also, the other reason why a lot of people are trying to integrate a lot more I/O for monitoring and diagnostics is because they're looking for a cost-effective way to add upgrades or options to the machine builds, right? You want to be adding easy to troubleshoot components through your I/O and combine them with some clear diagnostic messaging, right? So you can actually have it show you, hey, there's an issue at such and such point, and you can integrate some additional troubleshooting steps on your HMI to help your operator be able to diagnose and take care of any issues and get that machine up and running quicker, because it allows maintenance personnel and operators to get immediate feedback on their operations. And here's the other thing that we obviously don't consider a lot of times when we're talking about these monitoring. We talk about malfunctions, abnormal conditions. But what about normal operation, right? A lot of times you just want to know when an operation is done. So that's another great benefit of having the flexibility to add that and not need to worry about all the additional cost involved. So the great thing also about these little I/O logic modules is that they come in different flavors. You can have your digital inputs, your push buttons, your selector switches, your proximity switch. You can also have your analog inputs. Maybe you have some pressure level transducers, some flow meters. If you have sensors that use any 420 milliamp or make decisions based on current or voltage differentials, this option allows you to add your remote I/O and talk to in different ways to different people. Because of SNMP and APIs, you're able to connect it to your NMS or your network monitoring system to get status on it, right? And for the OT folks, you're able to take advantage of the protocols like Modbus and Ethernet IP to integrate it into your SCADA into your HMI. Okay, so this is just a quick glance at exactly the different types of flavors that it comes in. You have everything from your digital inputs, your relays, your analog inputs, your RTDs, thermocouples. This is a really awesome, inexpensive way to take care of a lot of different needs. You don't need to worry about having to buy a four signal card that's expensive and you need a backplane for. You can just throw this in there and don't worry about it because it's industrial. So it's meant to last. So with that, I'd like to jump into our second poll question. What are the most significant hurdles to updating legacy equipment, right? So is it installation and integration? Is it downtime, right? Is it service and support or interoperability with your industrial devices? I'll be honest with you, a lot of the feedback that we'd have from customers is that they are reluctant to immediately make an upgrade to their serial equipment because they can't really afford the downtime to upgrade, and not to mention the cost. So we'll go ahead and give it a couple more seconds here and just find out exactly what our audience thinks. Awesome. All right, let's see. Yep, this is, I guess, installation and integration followed by downtime. Yeah, interoperability with industrial devices. Perfect. Great. That's really good to hear. Okay, so we're going to go ahead and the next part of this is going to touch on some other really great solutions that we have and some of the top challenges for those proprietary protocols like the serial devices or maybe different protocols that you need to communicate within your plant. So here we have the serial, right? So how do you connect your serial devices to your Ethernet network, right? A lot of it has to do with the current serial device servers that maybe no longer have support with their drivers. Maybe you have some outdated software. Maybe you have commercial equipment that you're using that's not as reliable because you're in an environment that has a lot of, EMI or other issues with like maybe extreme temperatures or vibration. Also, serial device service setup can be pretty complex and time sensitive. So let's go over a couple of those issues and some of the solutions that we have for anybody looking to do that. So first, like we said, outdated software. You might have some software that's running legacy programs that is outdated, doesn't have vendor support because the vendor's out of business. Maybe you have no driver support and there's no updates, right? So as your processes improve, as your new equipment gets installed, as your new software applications get brought in, you're not able to plug this stuff in to connect to it and start communicating. The other is the fact that you have those proprietary serial protocols, right? So no network communication, no ports. Programming is very time consuming, and there's also a lack of interoperability. And this troubleshooting is difficult. A lot of times you have to physically be at the actual machine in order to be able to troubleshoot that machine and connect to it with your software that might be running on an old computer. So the good thing about what we're doing here at Moxa is that we are able to guarantee driver support until 2025. So you can go ahead and connect your serial device to your network and be confident that you're not going to worry about outdated drivers that you're not going to be able to use with the next Windows, or maybe you have a Linux platform that you're using. We also have the widest support for over 20 OS drivers. So we run the gamut all the way from some legacy Windows all the way up to Windows 10. And we give you 5-year warranty and free support on that. So it's very easy to configure, but if you do need help, we can help you out. The other thing is we have industrial reliability, right? Not to mention that Moxa is basically a company that started doing serial. That was our bread and butter. That's where we started. So we have a lot of experience with this stuff. So we know that certain applications require certain industrial certifications, right? You might need some NEMA certification or some hazardous zone certification, or maybe some rail for that vibration. We also offer you surge protection on both the LAN, the serial, and the power inputs, and secure installation, because these things come with some really secure linear mounts and they have screw connectors. They also have super high MTBF, so you can put this in and reliably be confident that it's going to be able to withstand whatever harsh environment you put it in. All right, the other issue, right? The complicated configuration. you are going to have a mix sometimes of really experienced engineers that have absolutely no tech know-how or don't really understand much about networking or how to configure a device. And you have things like virtual COM ports, or whether to use UDP or TCP client or TCP server. And you might have a younger engineer who knows more about the networking and IP side, but they're not really sure about the pinouts for the serial side, or whether how to configure how to run the cabling for a terminal versus a DB9, or non-standard baud rates, right? Or maybe the serial settings. You have things like data bits, stop bits. Is it RS-232? Is it 422, 485? Those are all some really important considerations that are important to consider. So the other thing about the serial devices that we offer here at Mox is that they come with a very easy to use, friendly 3-step web configuration wizard. It also works with the Telnet. It helps you monitor the traffic and manage the import remotely, right? So you connect this endport to your legacy device instead of having to carry over that cart with that computer to connect to it through a serial port. You can actually connect that and be able to use your computer from anywhere on the network, right? Or even be able to have somebody who remotely connects to your network access that machine now, because you have an IP address. Also, you have different operating modes and different features. So you have things like real COM mode, which allow you to be able to take that legacy device, bring it on board, and it doesn't know any better. It just thinks that it's talking to another serial port. But you have your application that you're able to install that virtual COM port, and now you're able to establish that communication, and you can get the readings, you can do the programming, troubleshooting, all that good stuff. Also, we handle non-standard baud rates, right? So that's a really big one, especially because we're talking about those industrial protocols. And lastly, security. Security is huge. We offer a line of these that have secure device servers, which have HTTPS communication, which basically means that you're able to encrypt the information going back and forth. And all the serial data, all the Ethernet packets are all securely and as well as transferred, as well as your login information, so you can protect yourself from anybody snooping around for that kind of stuff. So here's a really quick example of some uses and some of the benefits of having like a serial device server, like an endport, for instance. We have different versions that have either wireless, so you can do wireless to serial, or Ethernet to serial, or you can do both. You can actually run both a serial and an Ethernet line to your Wi-Fi with one single device. You can also just have straight serial to Ethernet, which means that you can do a lot of things like have multiple connections to your single device, right? And you can do the monitoring of the serial communication and the Ethernet communication, spot some issues that might be happening with maybe the cabling or the installation. You can also upload your CNC programs remotely if you have a CNC and be able to communicate with that machine like we said on your plant floor, and you don't need to be right next to it. Here's just a quick glance at the different products that we have. We have a huge range of offerings when it comes to serial connectivity. So if you're looking for security, we have our 6000. We also have industrial certified ones that have a lot of different certifications. We have wireless, we have rack mount, and combo servers. Those are really great because they have I/O and they also have, some of them also have Ethernet capability as well. So this is just keep in mind, and if you have any questions or would like more information, you can reach out and we'd be happy to answer any questions. All right, the next thing, gateways, right? So we have a lot of people that cannot communicate between protocols because they might have an Allen Bradley PLC and that thing's only Ethernet IP, and they have a lot of Modbus meters and they have all these other devices that they want to bring on board, but they can't. They're not interoperable. So you need to connect those devices somehow. So a gateway is a great solution for that. Also, like I mentioned earlier, it's very expensive to replace all of your serial devices with Ethernet devices. It's nice, but instead of spending thousands of dollars plus all the downtime, which you probably can't afford because it's running some critical process, how about being able to retrofit very easily with a serial device instead, right? The last is the need for scalability. The solution needs to be scalable, regardless of what you use or what vendor or what type of application you're working, because it has to work for many devices, and especially since your operation is obviously going to be growing, so you need to be able to be flexible with the changes. So this is something that's very important to mention, because the biggest industry trend we've seen for 2018 is a shift from the majority of what we see out there being field buses, like, your Profibus, your Modbus, your DeviceNet, being taken over now by the Ethernet-based ones. So like Ethernet IP, Profinet, and Modbus TCP. So in order to communicate with those field bus devices, to take advantage of all those great benefits that we talked about for the advanced manufacturing technologies, you're going to need something to help you make to bridge that gap between communications, and Moxa communication gateways help you do that. So let's take a look at an example of what I'm talking about. So let's say you have a standalone operation. You might have a run stop, a controller for a drive, and you have your PLC, and then you also have your VFD at the other end. Well, a lot of these are serial based, and maybe you want to bring it on board, but if you do that, the only option you have is to buy a network module, and those things are very expensive, and they can be very difficult to configure, and also sometimes the features might be limited depending on what model you get. So you really have to know what your intention is and what you need, and also keep in mind the flexibility for later. Here's the good part though. A lot of these, they come with the Modbus RTU already built in. So that means that you can take advantage of being able to bridge that gap by adding something like a MB3170, which is our M-Gate, which allows you to convert that serial data from your VFD into Modbus TCP, so it encapsulates it and sends it to your PLC. Not only that, you can have multiple slaves and you can have multiple masters. So you don't have to worry about just having one master pull that information. You can actually have different devices like a SCADA, a PLC, and maybe some analytics dashboard that's gathering information about your production. So you have a lot of flexibility. Or if you want to go the other way around, you could have a PLC that's RTU, that's Modbus RTU, and you want to be able to have it control some new devices that you brought on board that are already Ethernet based. There you go. You can do either or. So, and you can do Modbus ASCII and Modbus RTU. So it's a really great flexible option. The other thing is let's say you have Ethernet IP and you want to bring it on board to Modbus, like I mentioned earlier. Maybe you have a injection molding machine, let's say. Well, you can use an M-Gate 5105, for instance, and you're able to bridge that gap, and you can run a cable, an Ethernet cable, all the way down to wherever you need it to be, and be able to use that serial communication to daisy chain right at your temperature controller, and still be able to take advantage of all that data, control it, manipulate it, and get data from it as well. So, just to recap, here's some really great benefits about having a Modbus gateway. Again, it's about retrofitting and being able to still take advantage out of those assets. Everybody's trying to do more with what they have, and the more information you have, the better decisions you can make. And Moxa allows you to bridge that gap to bring those devices on board reliably, very easily, and allows a lot of flexibility because it's highly scalable, right? And like I mentioned, it does Modbus TCP, ASCII, and RTU. So the other great part about this, we obviously saw in the poll that we did that we have a lot of people that are struggling with the actual configuration and integration part of this whole retrofit, right, to bring those devices on board. Well, we got that covered for you as well. We have a really great, super easy to use configuration wizard that does a step-by-step process for you, so you can fill in all the information you already have, and you're up and running. The other thing, though, is that you can monitor that communication, so you can see if there's any. You can take advantage of those error codes, right? So maybe you configured the device incorrectly, and now you're able to tell that a lot quicker, and you can diagnose it. You can export the logs and have somebody review them. You can, if you wanted to troubleshoot a specific, maybe a Modbus protocol that might be giving you issues, you can export those logs and review them as well. So it's a really great configuration wizard, super easy to use, a lot of information, accessible, and you don't need to be an IT expert to use it. This is just a quick glance at what we're talking about. It tells you the connections and if it's listening or waiting to receive information. And this is just a quick overview of the different offerings and different gateways, different protocols that we're able to help you manage on your plant floor. We also have transparent and active gateways. So that's a really great option if you're looking for a rack mount server to help you monitor a lot of devices at one time and not worry about having it be a time-consuming thing, because it sends the information, pulls it for you, buffers it, and then sends it out when the master requests it. So it's a really great option. All right, next up, network complexity. So like we mentioned before, you want to be able to manage the network as it grows. But the more devices you add, sometimes people opt for using an unmanaged switch because obviously they're operations technology engineers, right? They're not IT folk. So if you are connecting these devices to unmanaged switches and you're using industrial protocols like Ethernet IP, you're going to be having some problems, and it's important to understand exactly why. So we're going to cover a little bit of that as well. And we're going to talk about some managed switches and how we make it easy for non-IT people to configure them and configure multiple ones actually, and troubleshoot them as well. And how to maintain all of those network devices. So we're going to touch on all three of those topics, which obviously are a big concern for our viewers today. So let's get right to it. So a lot of people use or really only know about two options when it comes to connecting those additional devices, right? They want to increase that port count on that managed switch that they have, and they want to add those sensors, the HMI, whatever, and they might want to use an unmanaged switch. Well, if you're using something, let's say like Ethernet IP, that might not be such a great idea. And the reason for that is because Ethernet IP uses multicast traffic. And multicast traffic, when connected to an unmanaged switch, becomes broadcast traffic. The problem with that is that all the traffic that goes in one port comes out all of the ports. There's no way to mitigate any of it or manage it, right? So although it is inexpensive and it is plug and play, you end up with things like jitter or network latency, right? Or broadcast storms. Not to mention there's no security. Anybody can connect to that switch, no problem. The other one is a managed option, which is great because you can do a SCADA integration, you got your redundancies, you got your IGMP snooping, which is what you need to mitigate that multicast traffic, VLANs. But the cons, this is where it gets a little, here's a rub, as they say. It's more expensive, it's more complicated to configure, and it can require some management, right? And if you don't have the IT personnel to devote time to maintaining, troubleshooting, and deploying these devices, it can definitely be easy to see why you would go with the unmanaged option. Here's the thing. We have a really great option here, which is our SDS 3008. And the reason it's so great is because you might be able to get away with using an unmanaged switch if you have a smaller, isolated cell, right? It's not connected to your network yet. You can kind of tell exactly the amount of traffic you have. But as soon as you start connecting more devices, you have you have multicast traffic. And the more multicast traffic, as soon as you connect it to another part of the network or other cells, then you're going to have a flood of traffic, and that's when you start to see issues with PLC timeouts or things not replying in the appropriate time, which can definitely affect the performance of your network and affect your production, obviously. So what makes our Ethernet, our SDS 3008 such a great option for those kind of folks that are looking for an easy to use, easy to integrate solution that's very cost effective? I'll do a quick run through. There's a lot of features, but I'm just going to touch the top four that I think are the main reason why you should probably consider this as your third option. First, IGMP snooping and querying, right? That alone is worth the price of admission because you're going to reduce your multicast traffic. You're going to reduce your latency. You're going to eliminate your jitter, and you're going to alleviate any issues with broadcast storms. The second is RSTP, which means that you're going to add some network redundancy. And it works with any existing switches because it's vendor agnostic. So if you have Cisco, you have some other brand, it doesn't matter. If they're using RSTP, this works well with that as well. It reduces your unplanned network outages. So you're going to tell me that somebody's going to spend all the time tuning the I/O, making sure that everything's running fine and it purrs like a kitten, but they're not going to want to have a secondary way to make sure that that thing doesn't stop connecting and producing. I don't think so. So it's a really great option that's included in SDS 2008. Also, security, right? It comes with port lock, which basically disables any open ports. The reason that's important is because I'm sure a lot of you can attest to this, but I've talked to a lot of customers in my time, either in conferences or just in person whenever I'm helping them find solutions. And they can all tell you a horror story of a third-party field tech that came on down to the plant floor, forgot the manual or a driver for a configuration file, and just saw an open port on the cabinet and connected to it and brought the whole network down inadvertently. That's what's called a non-malicious threat, right? So why not remove that from being a possibility? Why not make sure that you at least do the very least possible, which is locking down those ports if you have it in your cabinet. The second is SSH and HTTPS. This is a really great way to protect your usernames and your passwords and your data because it encrypts that communication between you and your switch. Then lastly is the industrial protocol profile. So you can monitor your congestion, your port statuses, because you're integrating it into your SCADA or HMI. So like in the example I showed earlier where it showed a fault on the HMI, you want to make it easier for your operators, because your operators, they might not have the experience, and it's going to be better for them and for you if you can simplify troubleshooting. So having that as a flexible way to integrate it is really great. Thirdly, obviously we said that making things easier for everybody was a key goal of Moxa. This is basically all you're going to need to do to configure the switch, and it's all here on one single page, no tabs, right? So you don't get multiple tabitis. You can go ahead and just click one button, and you can have it speak Profinet or Modbus or Ethernet IP, and you can enable SNMP as well. You also have your RSCP for your redundancies and your VLANs, and when you click Ethernet IP, you automatically enable IGP snooping, IGP query, and your SIP interface. So that means that you can read it as if it was a node on your network, on your SCADA system and your HMI. So that's a really great thing. So now that we've connected our devices, now that we brought them on board, how do we take care of the configurations, making sure that we do them right and not have issues with misconfigurations, and then when we deploy them, they're not able to install them? And how do you monitor to make sure that your network is online and that it's healthy and there's no issues going on? Well, we have a thing called MX Studio, and MX Config is a tool that is free, and it has a mass configuration. It allows you to do mass configurations, and MX View allows you to monitor any devices you have, and it's very easy to see. It's all very visual. You know, you don't need to dive in or do command line interfaces. It's there for you to be able to diagnose problems. So let's talk about the mass configuration, exactly what you're capable of doing with an MX Config. You can do things like add panels for VLAN cloning. You can add multiple settings like your passwords, your IGP snooping, your accessible IPs, traps, and also you can do multiple IP configurations at once. So you can do all of that and more, and also upload things like maybe you have a CSV file that has all the IP addresses you want to use for your scheme. You can use that as well. MX View is really great because it lets you basically see any alerts or any changes that happen in a very visual way. You can also set the switches to allow communication and send alerts, notifications, so you can keep track of that and get a good historical view of what's going on in your network. And if you're on the out and about, you can also have MX View to go, and you can get alerts. We've had customers actually tell us that they've been able to get an alert and contact the IT department before IT even knew, because they had this alert on their phone. So we were really pleasantly surprised to hear somebody being able to attest to being able to use that functionality. It's a great option, and it's free as well, like I said, for under 20 nodes. And after that, it's not very expensive either. So just to recap, we give you great tools for troubleshooting and for technical support without any additional cost. You get 5-year free warranty with that technical support, as well as security patches and firmware upgrades. All of that free of charge. So we want to make sure that it's easy, that you have the right support, and that you are guaranteed that you're going to have something that's going to last a lifetime. So with that, let's go ahead and jump to our third poll question. And what we would like to know is, where is your organization's adoption of Smart Factory, right? Are you just exploring the idea and its benefits? Do you have a pilot project that's built around, maybe taking advantage of some of this IoT stuff? Or maybe you fully embraced it. I'd love to know what we have in our audience today. I'll give it a few more seconds. Wow. Okay, we're closing this out. That's great. Okay, awesome. That's great. So the reason I say that's great is because I really hope that we provide you guys a lot of benefit with the information we're providing you today. We really appreciate you guys taking your time to participate and to check out exactly what we have to offer here at Moxa. And so in order for you to be able to make the best of upgrading your systems and taking advantage of all that IoT stuff, and you connect everything, you also need to be aware of the security concerns, right? So industrial cybersecurity is a hot topic. It's right up there with IoT. It's actually the second one, because like I mentioned before, you're connecting devices that weren't meant to be online, and now people can access them, because they have an IP address. Obscurity is not security any longer. So let's go ahead and just cover briefly some of the challenges to improve cybersecurity for industrial networks. So first, you have the lack of security features, right? you have things that might have devices like a network switch that might be out there that's configured to not lock out if you try logging in after multiple times, which makes it a very great target for somebody using a brute force attack, which means they can just try random passwords until it works and crack it. The other one is you can store the login and log out information. That's not good. You don't want to have anybody just go ahead and open up a web browser and be able to click log in because all the information is stored on there, as well as having configuration files with sensitive data like passwords. You don't want that either, because a lot of times, if that's the case, most likely that password works on a lot of other stuff on your network as well, right? The other one is unsecure network design. So penetrate one device, get access to all devices. Penetrate one network area, get access to the entire network, right? We don't want that, because you're increasing that, because now you're also having things like maybe somebody remoting to access a device to do some maintenance, and you want to make sure that you limit and monitor exactly what that person is doing. You might want to have the security in place to protect your serial or your legacy devices that you're bringing online, and you don't want to have that be a vulnerability to be able to access your entire network. You don't want somebody to access one serial port and access your email server, or access your client information, or your customer data, or any of your employee information, or maybe even take your secret sauce, right? Protect those trade secrets. Then there's difficulty managing the security during the network lifecycle. Basically what that means is forgetting to change passwords whenever you add a new device, forgetting to activate the security settings after you do a maintenance on the part of your nodes or your network, or using unsecure connections for anybody that's requiring access to do some service on your devices. So Moxa's approach to security when it comes to manufacturing or industrial practices anyway, is we follow IEC 62443, which means it's a three-tiered approach. And you start with a device level, right? So all of our devices are hardened devices with embedded security functions. Then we have the network security, right? That means that you have your defense in depth, which means that you have cybersecurity networks that are segregated, that are segmented, and that have firewalls and things protecting unauthorized access to those devices and to those parts of the network, right? And thirdly, you have security management. So being able to define policies and then having constant security visibly to manage all of your network is a really important component of this, because just because your stuff is on the network, it's secured and it's segmented, doesn't mean that you don't need to worry about either it going down for some issues that might happen on your network, or maybe somebody is tampering with it. So you want to have that visibility once your stuff is out there. So how much security do you actually need, right? That's a great question, because if you look at this threat assessment model of risk versus cost, there's some things that you can do early on that allow you to take advantage and reduce the impact or mitigate the impact of any issues or any threats that could be out there. So things like having the right security features on your devices you're putting on your network, or having the right segmentation. Those are not expensive. What is expensive is having to have a security audit and have to pay ransomware and have to pay for additional security functionality after there's been an issue or a breach on your network. The whole point is to do as much as you can up front from the very beginning to create a great foundation so that you can build on that, and then you can reduce the amount that it's going to cost you to make sure that you maintain that level of security. Okay, so now here's the top 3 vulnerabilities for ICS. ICS, by the way, we're acronym crazy over here at Moxa. It's Industrial Control Systems. Okay, so like we talked about earlier, the lack of security features. There are a lot of important security features for network devices that users should enable to protect the network devices, like connection authorization management, or key configuration, or password protections. Increase the password strength, right? You don't want to have somebody using 1234 or password, or leaving the default password. And also you want to enable some log recording, or even some syslog servers to record what's going on your network, right? To find out what the operation is of your devices, or if anybody's trying to break in, or just any weird things that are out of the norm. Without these basic features, at the end of the device, it becomes a very weak point in your network. All right, so for that, we reinforced our E-series switches with the account management, the password policy, encrypting the configuration files, login authentication, and even account lockouts, right? Makes it very easy. And also you can control what IPs and what type of traffic you want to allow to communicate with the device. Just because you can connect to it doesn't mean I want you to be able to access anything. I want only Modbus communication to hit this specific device behind that switch, right? So it's a really great way to secure the network by adding that port security and that access control. Next, we have unsecured network design, right? So these devices that we're bringing on board, they really can't protect themselves, and it's important to be able to have all of the security things in place to be able to secure and prevent anybody accessing other parts of the network. I know I've said it a lot, but I honestly can't say it enough, because that's a really big issue with a lot of these control systems. People are very laxed when it comes to installing and maintaining these networks. So you don't want to have anybody you want to be able to have things in place like, let's say, a firewall that can block anything from going into the device that's not Modbus traffic, like I mentioned earlier. Or maybe you only want a read access to that. You don't want it to be able to write to one of the coils. It's important. It's important to make sure that all the security is in place. This is number one, aside from having the devices that have the functionality for security, having the right network design is definitely key. And the reason for that is because you have to make sure that you have a good assessment and an audit of what devices you have on your network, and making sure that whatever devices are on the network communicate to the devices that they're supposed to, and only those devices. You want to control who can talk to who and how they communicate, right? So you need to have constantly developed countermeasures that are going to mitigate any risk, that are going to be able to be verified and make sure that they work. This is an ongoing process. Cybersecurity is not just a one and done. This is going to be something that you continually have to monitor. And part of that is making sure that you're able to assess for new threats. And remember, as your security gets stronger, the cyber attacks get smarter. That's just the way that it goes. So you can't really ever rest on your laurels just because you have stuff out there that's secure. You always have to make sure that you're making sure that you have the right security in place and the right policies, number one, right? So you need to apply conduits that can examine the different traffic. So maybe you have your enterprise level at the top in the green box there, and you want it to get the data so that they can process those dashboards to get the analytics, but you don't want it to talk to the SCADA to get that information. So you want to have a DMZ between it. You want to have something that can broker that information and also allow the SCADA to dump and process the information so that it can be accessible to your higher levels. You also want to make sure that certain segments, certain zones don't communicate with each other, or that if one segment is open, it doesn't, just because you infiltrated that doesn't mean that you can access the rest of the network. So defining these with the device requirements and identifying the kind of traffic over conduits, which are basically firewalls, is very important. Next is security management during the life cycle, right? So when your network is deployed, you did everything to protect it, you got all your secure connections, all the security features are enabled, but what happens at day 100, right? Your passwords did not change when your new device was added. Your security settings were not restored after you did some maintenance. Your default passwords weren't changed. You know, you might have some insecure connections from a remote tech that requires access to your network. So you can't get laxed about these requirements. And the reason for that is because as you mature in your cybersecurity journey, you're going to start with the first three that we talked about, which are your secure devices. Then you're going to have your gateways and your firewalls, and then you're going to have things like whitelisting and your access controls and your zone firewalls and your DMZs, all that good stuff. But that's more of a passive, like we said. You just did the foundation work. Being active when it comes to taking care of any threats and getting what's called threat intelligence requires you to participate in managing and having a good idea of what's going on that network. So you want to be able to manage any incidents and have something in place that you can do to react to some kind of threat that might have affected your network. But also you want to be able to have the historical information about how your network is supposed to run so that you can detect any anomalies or detect anything that might be odd, or any threats, or somebody trying to hack into your system. So you can start to anticipate a lot of things as soon as you start becoming proactive. But first, you need the foundation. So in order to help you do that, we have things like MXView, like I mentioned earlier, but what I did not mention was that it has a security level, which is MXView Security View. It has a level that shows you color-coded information about what your devices are configured to. Now, like I said, we use IEC 62443. That means that we have certain standards and certain things need to be enabled, like your auto logout, your password, your password strength. So this tells you very quickly, very easily, hey, this device has basic, and maybe you want to enforce a little bit more. Maybe this has medium, or maybe this is higher. Maybe that's an open device because it doesn't have the security features because it's an older device. Maybe you want to have something in front of it so that you can protect it. So the key features of it are that it's super flexible, very easy to use, and it's meant specifically for industrial networks because you're able to see things in real time, right? And it's convenient. You can monitor it. It's very time saving, and you can select the standards that you want, and you improve the control over the security status of your network. The other great thing that we have is MXConfig. Like I said, it's a great mass configuration tool. What I didn't mention about that one as well is that it has what's called the security wizard. The cool thing about that is that it's able to select from the drop-down menu, hey, I only want level 1 on this one, or I just want general baseline, or I want level 2, very high security on this device. You can go ahead and select whatever security setting you'd like on the profile, and then go ahead and apply it, and you're done. You've secured your device. So even if you found that you have a device that maybe during the maintenance didn't get restored back to what it should be, you can go ahead and find out what device that is, where it's located, its IP address, and then use MXConfig to go ahead and manage that and immediately fix it and correct it so that you don't have any vulnerabilities on your network, right? So it's convenient. It's got a lot of great security-related functions, and you can, again, improve the control of security and statuses of your network device. All right. So that was it for me. I know we covered a lot of topics. I know that it was a lot to take in, but hopefully you found the information beneficial and that information that you can use. Really thankful that you were able to join me today, and we're going to go ahead and leave it open, send it over to Scott so that he can go ahead and take any questions you guys might have.
All right, thank you, David. Thanks for a ton of really great information. So just a quick note before we get to the technical questions. You guys will receive a copy of the recording typically within a couple days after today. So by Friday, you should have that to review a lot of the information at your leisure. So just wanted to make that that note. So with that said, why don't we dive into the questions? We have a few minutes left. So question number 1. Will migrating to Ethernet require me to reconfigure all my original serial device settings?
That's a great question. Actually, no, it will not. In short, basically the import, what it does, it's able to let you import and use the exact same serial settings. The only thing that changes is what you want to do, right? So if you wanted to communicate with an application that uses virtual, am I online? Yeah, okay. Yeah, sorry about that, guys. So yeah, you don't need to change anything on your serial device. You don't. You just are able to transmit all that information over your network, and you're able to get it to whatever you need to get it to. So it could either be I don't know, an application, or it could be a controller, or it could be some kind of a master that you have. And the other great thing is that our imports come with a really great set of additional features like delimiters and data packing, which basically let you use special characters to know when to stop and start transmission of serial data. The reason that's important is because you guys are using a lot of serial proprietary protocols, and sometimes they don't use very standard like data lengths. So we have things like force transmit, data packing, delimiters, first in, first out. So yeah, you don't. The short answer is no, you don't.
Great, thanks, David. So question number 2, looks like I have heard of ISA 99 and NIST 800, but I'm not familiar with IEC 62443 standard. Can you explain?
Yes, thank you. That's a great question. That's actually a security standard that's adopted across the board by some of the major manufacturers and larger companies, basically anybody in the industrial space. It's basically ISA 99 was adopted by IEC 62443. So the way it works is NIST 800 is basically a framework that describes the outcomes, right? The what, where IEC 62443 defines how and how much security you actually need, right? So NIST 800 is more of an informative reference for IEC 62443, but they both work hand in hand.
All right, great. Thanks for that. So looks like we have one more question. What is the difference between an industrial NMS and the enterprise NMS that my IT department uses?
Okay, another great question. Although they both serve the same purpose of monitoring and maintaining your network, there are some very key important differences. So first, an enterprise NMS is going to visualize the network from a logical link perspective, right? So an industrial NMS is going to show you physical connections between your devices. So this makes it a lot easier to troubleshoot your hardware problems, especially if they're out in the field. And it's also a lot more consistent with the way that a SCADA system would show a connection and monitor those connections. The second is the fact that it has event alarms and alerts that are in real time. So in an industrial NMS, because we need to know immediately when there's an event that could impact reliability, it's important to get immediate information and feedback on those kind of issues.
Fantastic. Okay, that's actually all the questions we have for today's webinar, so we're going to wrap things up. If you have any other questions or if you need help on a specific situation or issue down the road, please feel free to reach out to us directly at usa@moxa.com. Also, you'll see a survey after the broadcast. If you could spare a few more minutes to complete this so we can gather your feedback as a way to improve our future webinars, that would be great. Thanks again for everyone for joining us today. Have a great rest of the day.